Good morning, everybody. Today we are continuing topic 9, which is all about congruence of triangles. And today's lesson is lesson 9-4, ASA and AAS congruence criteria. Well, before that, let's review the two criteria we have learned from the last lesson. The very first criteria that we have learned in the past is something called side-side-side congruence criteria, as abbreviated as SSS. And it just means that if you have two triangles where you have three pairs of sides having the same length with another, then the two triangles are the same size, same shape. In other words, if segment AB has the same length as segment KL, which is indicated by the green tick mark, and segment BC has the same length as segment LJ as indicated by two tick marks in blue, and segment AC having the same length as segment KJ as indicated by three tick marks in pink. So if you have three pairs of sides that are having the same length, then the two triangles are congruent. So if they're congruent, to write a congruent statement, it's going to be triangle ABC. So you could scramble the letters any way you want for the first triangle. But for the second triangle, A matches K, B matches L, and C matches J. So you have to follow the corresponding corners or angles for the second triangle. So that's your congruent statement. Well, for the second pair of triangles, I see that they do have a pair of sides being the same length, and then another pair of sides being the same length. Now, I only have two colors, so then you probably wonder, where is the third color? Well, if you notice, these two triangles are sharing this side right here, segment AC or side AC. So in a way, well, technically, they both sharing this side. That means this side, the overlapping side, are having the same length from both triangles. So that means we could actually create a three tick marks mark, so that way we see that there are three pairs of sides being congruent, and therefore we could use SSS to show that these two triangles are same size, same shape, or congruent. So to write a congruent statement, we're going to say triangle ABC, the triangle on the left, is congruent to the triangle on the right, which we have to again match the letters. So A matches with itself, and then B matches with D, and then C matches with itself, and that's your congruent statement. So this is your SSS, or side-side-side congruence criteria. The second congruence criterion that you have learned from the last lesson is called SAS, or side angle side. That means that if you have two pairs of sides congruent to each other, and then you have one angle in between the two sides, then these two triangles are same size, same shape, or congruent. So to make sure that the angles is in between the two sides, let's say, for example, if I were to color this side in blue colors, just like this, right? And if I were to color the other side with green color, as demonstrated here, right? You notice that the two colors, they intersect, they cross at this corner. And since we have the angle mark at this corner where the two colors meet, this angle is considered in between these two sides. So likewise, this angle is considered in between these two sides. So therefore, we have an SAS congruence criterion for these two triangles. So to write congruent statement, we say triangle MNO for this triangle is congruent to, for the second triangle, we have to match the letters. So M matches R, and then N matches P, and then O matches Q. So that's your congruent statement for this pair of triangle. Well, for the second pair of triangle, we see that there are two sets of tick marks that tells you that the sides that marked in pink colors are the same length, and the sides that marked in a green color are the same length. So far you have a pair of sides, and we're going to just write it with the same color. And then we also have another pair of sides, in another color. Now you're like, well, I don't see any angles mark in this diagram. Well, back in in the past, you learned that, well, vertical angles are created by cross. So if you see a cross, then that means these two angles are vertical angles and they're congruent. And these two angles are in between the two colors, right? Are in between these two sides. So even though there's no angle marks here, you know from the past that vertical angles are congruent. So therefore, there is a hidden angle marks that you have to create to show that, hey, there is a pair of angles that are congruent, having the same degree measure. So therefore, we have an SAS for this situation as well. So to write a congruent statement, we're going to say triangle ABO is congruent to triangle A matches E, B matches D, and O matches itself. So ABO and EDO. Well, once you have learned and reviewed these two criteria, we're going to lesson 9-4, where you're going to learn 3 more congruence criteria. In lesson 9-4, the title is called ASA and AAS congruence criteria. Well, let's take a look at the first criterion in this lesson. Well, the first criteria is called angle side angle congruence criterion. It says that if you have 2 pairs of angles, right, so we're going to highlight them in colors. Let's say this one is in green. So if you have 1 pair of angles being congruent or having the same degree measure, and if you have another pair, the second pair of angles, having the same measure, as well as a side in between. Let me use a different color. Let's say use an orange, right? And this side has to be in between the 2 angles, right? Same thing, this side has to be in between the 2 angles. Then these 2 triangles are congruent. So we're gonna say triangle MNL is congruent to triangle SRT. So that is the angle side angle congruence criterion. Well, similarly, there's something also called angle side congruence criterion. So this time, if you have 1 pair of angle, let's actually highlight them in pink, that having the same measures, same degree measures, and then if you have another pair of angles being congruent, in other words, having the same degree measure, and then you have 1 pair of sides that is not in between the 2 angles. Okay, so it's just like on the side of the 2 colors, the green and the pink color. Then these 2 triangles are also congruent, or same size, same shape. So we're gonna say triangle UVW is congruent to triangle XYZ. So we're gonna use these 2 criteria plus the 2 previous criteria from the review to take a look at whether 2 given triangles are the same size, same shape, or congruent. Let's take a look at these 4 examples, example 1A, 1B, 1C, and 1D. We'll start with 1A first. In example 1A, you're given these informations and they want you to find out whether these 2 triangles are congruent. The best way is to use different colors to indicate to highlight the given information. So first, I see that there is a pair of angle marks so that I know that angle A is congruent to angle E. Then second, we also see that there's a pair of tick marks on the side, so that's your S right there. Let me actually just put these letters, right? Since we have a pair of sides, we're gonna write S. And since we just highlighted a pair of angle, we're gonna use an A, right? So we have S and A so far. But then there's one hidden information. Just like from the review, you learned that if you have a crisscross in the middle, there is a pair of vertical angles that are being congruent. It's a hidden information that you have to find it out yourself. So therefore, we have another A that we're gonna write here. Now, we wanna make sure that, should we write A in front of these 2 letters, or should we write A at the end? Because if you look at the diagram, this blue tick mark is in between the 2 angles of different colors. So therefore, the S must be in the middle of both A. So therefore, we have an ASA congruence criterion. So are they congruent? Yes. And it's by ASA. And therefore, we could write the congruent statement. Triangle ABC is congruent to triangle EDC. In example 1b, very similarly, we're going to highlight some given information first. I see that there is a pair of sides with 2 tick marks, so we're going to put an S at the corner. Then at the same time, we also see that there is a pair of 3 tick marks, top and bottom, and that's also a pair of sides. We're going to put another S. And that's it. We don't have other tick marks anymore. But if you notice that these 2 triangles, they both share the side in the middle, CV. So technically, it is congruent to itself. CV is congruent to itself, so we have another pair of sides. So therefore, these 2 triangles are congruent, and by the criterion SSS from the previous lesson. And if that's the case, we could write the congruent statement. So triangle AVC is congruent to triangle JCV. A matches J, V matches C, and C matches V. In example 1C, we're going to do the same thing, this time with numbers. Well, since they both have a length of 4 on each of the triangle for the sides, that's a pair of sides that is being congruent. And we also have a pair of 6 that also tells me that there is another side that is another pair of sides that is being congruent. Now again, you have a crisscross in the middle, so you have a pair of angles, vertical angles, and that's an angle. Now this angle is not in between the 2 sides, okay? So we have something called SSA, and this is not really a congruence criteria. So therefore, are they congruent? The answer is no. I actually made a typo. It should be a no. And if so, which criterion? Well, this time is none because they're not congruent in the first place, and therefore we do not have a congruent statement. Well, on the final example, example 1D, I pre-highlighted these angles for you. So I see that there is a pair of angles in pink, so we're just going to put an A. And then there is also another pair of angles in blue, so that's another A right there. And then at the end, we also see a pair of tick marks. We're going to highlight it in orange. And this pair of sides are not in between the 2 angles. So we're just going to put the S at the beginning or S at the end. And it doesn't matter. It could be AAS or SAA. It doesn't matter. As long as the S is not in between. So in this case, are they congruent? The answer is yes. If so, by which criterion? It's AAS or SAA, doesn't matter. And if so, the congruent statement is going to be DOG, is actually spelled as a word, and D matches C, O matches T, and G matches A. Well, very similar to the last lesson, we're going to take a look at ways to prove that 2 triangles are the same with additional information needed. So here it says, given the 2 triangles on the right, what additional congruent statement is needed to show that triangle DFE is congruent to triangle LJK by one of these 2 criterions? So first, let's actually highlight some given information. I see that there is a pair of angle marks, and we're going to highlight it in purple. So therefore, we have a pair of angle. And then at the same time, we also see that there is another pair of angle marks. Here, we're gonna highlight it in orange. So that's an A right there, okay? And if I were to really prove that these 2 triangles are congruent or same size, same shade, by ASA, I need to have the middle pair of sides between the angles having the same length as well. So in this case, the side that is in the middle is going to be DE and KJ. So we're going to say that means the third pair of information I need is segment DE has to be congruent to segment JK. Well, to prove it again by AAS, we're going to pick another pair of sides that is not in between. So there's actually 2 sets of answers for AAS. Either you could pick the sides on the top, or you could pick the sides EF and LK. So there are 2 sets of answers, and they're both acceptable. So either you're going to say segment DF is congruent to segment JL, or you could say segment FE is congruent to segment LK. Well, so far we already learned 4 criteria from this lesson and the previous lesson. The final criterion to prove that 2 triangles are congruent is something called HL, which stands for hypotenuse and leg. So let's take a look at this congruence criterion. It says that if you have two triangles and they must be right triangle, that means that I should see a box or 90-degree angle marks in both triangles. So in two triangles, if their legs, doesn't matter which one of them, if their pair of legs are having the same length as well as the hypotenuse also having the same length, then it's good enough for us to say that these two triangles are congruent. So just like demonstrated in this diagram, right? And that means the congruent statement is going to be triangle ABC is congruent to triangle MNP, okay? And remember, this is working because of the Pythagorean theorem. So in other words, let's say you have a triangle, a right triangle. Well, if I know that this is 4 units long and this is 5 units long, right, we could easily use Pythagorean theorem, right? So like, a squared plus 4 squared is equal to 5 squared to find the missing length. And if you were to solve it, a is equal to 3. So once you know that there are two sides having a known measure, length measure. So if you have two sides, then you know how long they are. Then you can use Pythagorean theorem to prove or to show that, hey, what is the length of the remaining side? So this is technically in a way that is SSS, because if you know two S's, you could know the third one by using Pythagorean theorem. And that's why HL works, but only for right triangle. If it's not right triangle, you cannot use HL. Well, let's take a look at two examples of using HL to prove that two right triangles are congruent. Well, here we have two triangles here, and we first have to make sure that they are right triangles. Well, one of them has the box, but the other one does not have a box. But here's the thing. You learned that in the past that a straight angle, right, this line right here is 180 degrees. And if one of them is 90, then you could do 180 subtract 90, and you still get 90 degrees. So technically, even though there's no box here, we could actually create a box to show that, hey, these two triangles are right triangles. Well, here we have their hypotenuse being the same. Hypotenuse is the side that is across from the right angle. So we have a pair of hypotenuse being the same, so that's H there. And then we don't really have any take marks to prove that the legs are the same, but look at this leg here. Well, for this particular leg, they both share the same length, OC. So therefore, this leg is actually congruent to itself. So we could actually create a take mark on our own. And that's actually the leg of the right triangle. So since you have H, the hypotenuse, and L, the leg, and you know that there's a right angle in both triangles, then these two triangles are congruent. And so we're going to write the congruent statement. Triangle AOC is congruent to triangle DOC. Well, let's take a look at one more example. In this example, we have two triangles, and one of them has a right angle, and then the other one does not have a right angle. But remember, since you have a crisscross here, vertical angles are congruent. That means if this is 90 degrees, then this is also 90 degrees. So that way you know that these two triangles are right triangles. Well, same thing. We also have the hypotenuse here being congruent. So therefore, there is a hypotenuse here. Okay. There's an H. And then similarly, we also see take marks to indicate that one of their legs are also congruent to each other. So you have an L as well. So since you have a pair of hypotenuse, a pair of legs, and you know that they're both right triangles, then these two right triangles are congruent by HL. So to write a congruent statement, you're going to write triangle RKP. RKP is congruent to triangle R matches M, K matches N, and then P matches itself. Well, that's it for this lesson. Now you learn 5 ways to prove that two triangles are congruent. You learn SSS, you learn SAS, and then in this lesson you learn ASA, AAS, and HL. And the next couple minutes is to remind you how do you log on to your Pearson's homework. Thank you. Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource, and then you go to a place called Pearson Savas Easy. Pearson Savas Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that, and you get to this pop-up page, and you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. You click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks. So if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're gonna click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on the click into the assignments, and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on, which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the 3rd time that you got it wrong, it'll tell you the answer right away. So, but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now for this problem, what do you do when you get it wrong, right? So, well, to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So you click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that it's not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it, and then boom, I only got 3% just because I only answered one question correct, the rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.